Hi everyone, I'm Prabhat and let's talk about large language models. You would have worked on ChatGPT. You can ask different kinds of questions from it and will get very accurate results. These models are trained on a lot of public data and can solve use cases like question answering, summarization, and planning. The only problem is these models can answer what they are trained on. So let's say you work in a company and that company has a lot of private data. What if you ask questions to these models related to that data? The kind of response you will get would be very inaccurate, mostly because those models are not trained on this private data because it was not publicly available. Will it not be useful if you can ask questions to these documents in your company and get response out of it? We can solve this problem. There are two ways with which we can insert knowledge in a model so that it can answer questions on the private data. The first one is fine tuning approach and second one is called in context learning. Before getting into these, let's take one example and try to understand it. Let's say you have a support executive in a company and you want to ask questions related to a product to that support executive. The only problem is that guy has never worked on the product, has never gone through any documents related to the product, so has no context of that product. How would he answer accurately if he has never seen the product or heard of it? The two ways we can approach this problem is first, we share all the relevant documents of the product, we give him access to the product and ask him to spend a lot of time on these documents and the product itself so that he is well trained to answer questions on the product. That's one. The second approach would be we can ask question with sufficient context. So let's say I want to ask question related to a very specific functionality of the product. While sharing the question, I can share all the relevant details attached to this functionality. In this way, that support executive will have sufficient context upfront in order to answer the question. So the large language models work very similar to this. The first option is fine tuning, that is training them. And the second is when you ask the question, you share sufficient context to the LLM. Let's go through the first approach, fine tuning, that is training. You can initiate a training process using gradient ascent, reinforcement learning, or any other optimization process to make sure that this knowledge is encoded in the weights of the model. Few components that make it difficult. First, the effort needed in preparing data in the right format for fine tuning. The second one is lack of transparency because we cannot peek into these weights and can for sure know that the model has been trained based on our data. And third one is when you have huge amount of data, it is going to be a very expensive process. And let's dive into the second approach, in context learning. When you ask a question, you search for relevant context in your private data, and then to LLM, you share the complete context with the question. So think of it as to LLM, we are asking a question, a large question, where we are sharing the context first, and then we are appending the question. In this way, this complete question would have sufficient information for the model to scan through the context and answer the question. Let's take an example to understand it better. We have a PDF document that has some content, and we would like to ask a question. The question is, what do you think the map will reveal about Emily's next adventure? What we can do is we combine the document and the question together in a well structured format. That'll be the prompt to NLP. The structure would be something like, here is the context and the complete document we are going to keep there, and then given the context, answer the following question, and we can append the question after this. In this way, our initial question has changed to this prompt. What's next? This prompt is going to act as the question and will be asked to the large language model, and the model can then answer because that model will have sufficient context for the question. The key challenges of this in context learnings, first, is how to retrieve the correct context for the prompt. Second is how to deal with long context. And what about dealing with different types of data, structured or unstructured? The example which we saw, where we said we are going to have a document, we are going to ask a question, we append the complete document as the context. The only problem is the size of document can be huge. And with that, the initial prompt to LLM can be very huge. The larger the size of the question asked to the model, the more is going to be the computation power needed, and it is going to be an expensive process. It is going to take a lot of time. So generally, to optimize this, instead of sharing the complete document as the context, we scan through the document and grab just the relevant contents associated with a question. So the first question that has been asked is how to find that correct context to optimize this whole process. The second one is sometimes the question would be related to summarization, and in this case, we have to share the complete document. How to deal with that? So, all of these questions, let's solve them one by one. First, how to prepare the right context. We have a document, we have a private data. We would want to create a context query out of it based on the questions asked so that we can push it to LLM. We need a mechanism to do this. What we can do is to add a layer in between this private data and model, that is data connectors and indexes. This layer is going to load the data, reshape it in the right format, which can optimize the whole process, add indexes to it so that searching the right context is easier for us, and then we create the context query. So what is within this data connector and indexes? Before we talk about data connectors, let's try to solve this problem as a programmer. We are given a question, we are given a document, and we have to find out the right context of this question in this document. As a programmer, the first approach would be the question is of type string. We chop this question into different words and we try to find all of these words in this document. We can find those sentences that will have the words which we were searching for. We grab all of those sentences, combine them together, and use that as context. The only problem with this approach is language is not that simple. Word in different sentences can have different meaning to it. And the second one is two related words can be contenders for context, even if just by string comparison they are not equal. For example, cats and dogs. Although in string comparison we are going to get they are not equal, but in category of pet they are together. And in this way, it is possible that in question there is a mention of cats, and in the context of the document, we would want the sentence where we have dog. So, in order to solve this problem of finding the right meaning and the related words in the context, we would like to reshape our initial document and question into a different format where all of these meanings and relations are stored so that we can do a better comparison. One of the ways to make this happen is through embedding. That is, you convert all of these words into numbers and you plot these numbers into n-dimensional metrics. The words that are related and the words whose meaning is close to each other, we can keep them closer in that n-dimensional matrix. And in that way, every word can be converted into a number and the related words would be closer in number. And in this way, we can search through that matrix of numbers and can find all the numbers that are close to our question based number. Then, because we would have converted our question into a number, we have this document, all the sentences of the document and all the words within the sentences as different numbers. We scan through our question number into the document numbers and find out all the relevant numbers. So let's talk about data connectors and how they've solved this. So our private data goes through two stages. First is splitting and second is embedding. Why splitting? Because there is a context limit. There's limit on the amount of words or token you can pass to the language model. And second is to increase the signal to noise ratio. A document can have a lot of different punctuations, connector words like and, or, and even by removing a lot of these connector words and punctuations, we can still keep the meaning of the document intact. And by reducing the size of the document, we are increasing the overall processing speed. And then embedding takes a piece of text and creates a numerical representation of the text. So texts with semantically similar content will have similar vectors in the vector space. And so we can compare the embeddings and find texts that are similar. Once we have document embedding ready, we can grab the question, convert it into number. We can use this number to scan through the document embedding and find all the numbers that are similar to the question embedding. We filter out all those numbers and use that as context. So our final structure, which we are going to push to NLP, will have the context which we have searched from the document embedding and the question, the initial question itself. Let's add a database module in front of document embedding. We can use vector database to store all of these embeddings. And then question embedding can search the context in this database and get the relevant context.